Hello everyone, and welcome back again to part 5 of the OrCAD X Capture tutorial series. My name is Adam Fuchs, I am a product engineer at Cadence Design Systems, and in this video, we're going to complete the schematic by adding all the components to our microprocessor and peripherals pages, and make sure that all of the connectivity is done in our schematic. By now, if you've watched the previous two videos, all of you are pros at creating and managing the library in the Component Explorer, whether it's adding a new component, adding a part from a third-party library, or even creating a part from scratch. So for this video, I'm going to go ahead and reuse some of the parts that I've created in the past. If you want to know which parts to use with which symbols and which footprints and which properties to include, I'm going to add a spreadsheet or a PDF down the line, just so you can see which schematic parts should be used with which footprints, etc. So let's go ahead and get started. In the previous video, we completed the power page. Let's jump into our microprocessor page. In my Component Explorer, I'm going to go into my workspace where I actually have a lot of uncategorized components that I've created in the past. And I'm going to go ahead and select one of these microprocessors here. And we're going to place it on the schematic. This is our main microprocessor for this design. It's an ATSAM D21G18A. And we're going to go ahead and connect up all of the power pins and all the different I/O to our power delivery, as well as the peripherals in our design. So first things first, let's go ahead and add a reset circuit in the form of a switch and a pull-up. Go into my Component Explorer. We are looking for a switch. There's my switch. And I'm also looking for a 100 nanofarad capacitor and a 10 kilo ohm resistor. At any point, you can always copy parts from other pages. OrCAD X Capture is smart enough to understand that you're grabbing a reference to another part in your library, so you don't have to worry about it. Simply just Control-C and Control-V the part between your schematic pages. Let's go ahead and add a 100 nanofarad capacitor. And connect this up. You might actually want to move these up a little bit, as we're going to need space for our power pins here. And we're going to use this 3.3 volt power net, which we created on the power page, pretty extensively on this microprocessor page, as well as the ground symbols. Okay, so we have a reset here. As the switch gets pressed, this will go from being pulled up to pulled to ground and should reset the device. Now let's go ahead and connect the power pins. So VDD in, VDD IO 1 and 2, and VDD analog all go to the same power net. So we'll connect it like that. And then we need to add 4 decoupling capacitors on this power net, each of them 100 nanofarads. Again, I'm using the Control-C, Control-V to quickly place copies of the component. And notice that the reference designator automatically gets incremented to the next available reference designator. If you make a mistake, simply press Ctrl Z, or you can go into Edit, Undo. Whether that's placing a component, moving it around, placing a wire, pretty much any action can be undone. We also have this VDD core, which I believe is an internal voltage that is brought out to one of the pins. We'll go ahead and add a 1 microfarad capacitor to that pin. And we'll also call the power net on it VDD core. Plus VDD core. Next, we have a couple ground pins which we want to connect to the ground. Very easy to do. And the E-pad as well is connected to ground. One other thing that we need to connect for this microcontroller to work is a crystal oscillator. Well, actually, I think this crystal oscillator is just for the real-time clock. Let's go ahead and add that in. I believe I have a crystal part in here. Yep, so ATF Xtel. Let's add this part in. Now it needs 2 9 picofarad capacitors on both of its pins. Here's the 9 picofarad capacitors. And these are connected to pins PA00 and PA01. And then the capacitors need a ground pin as well. There's also an analog reference pin, which is PA03. So we can connect that up to a 1 microfarad capacitor. And we can go ahead and place a net alias here, call it aref. And that's good to go. Pin PA16 we're going to use as just a heartbeat indicator. So let's go ahead and copy our LED from our previous page. We want to connect it to this PA16 here. We'll go ahead and rotate it around or mirror it. And also add a resistor in series just to make sure we don't burn our chip here. And we're going to use a 10 kilo ohm resistor. And we'll connect that up again, connected to ground. This microprocessor also has a header for programming. We're going to place a 4-pin header here. This is in my connectors. It's this connector header through hole 4 position. Let's go ahead and place that. These are pins PA30 and PA31. Where PA30, let's place an alias here. SWCLK pin. And PA31 is SWDIO. I can't remember what this stands for. I think it's serial wire clock and serial wire data input output. Don't quote me on that. It's been a while since I've used that interface. But let's go ahead and add, this also needs a ground and a power net on it. And ground. Perfect. And now all we have left to do on this microcontroller is to connect all of the general purpose I/O pins. So first thing we'll do is let's go ahead and connect up our USB interface to this chip. So if we look on our power page, we have these DP and DN off-page connectors. We can go ahead and just copy those over into this page and paste them. I happen to know already that DN goes to PA24 and DP goes to PA25. Now in this case, we don't actually need to add an alias. In fact, we didn't have to in the other, on the power page either. If you use an off-page connector and it's named, then that name automatically gets used as an alias for the wire that it's connected to. So we don't have to copy one of these aliases and add a D_N here. We can just leave this off-page connector. One other thing we want to add is also the LCD power enable that we had on the power page. Just to show how the off-page connectors work, on this page, I'll just draw a wire and add an alias. We're going to place net alias and call it LCD power enable. And then if we look in our DRCs at the bottom, we should see some warnings. We have two nets in the same schematic have same name, but there is no off-page connector. There's one that says net has fewer than 2 connections, and then the same thing, two nets in the same schematic have the same net but no off-page connector. And these you can see are actually shown on 2 different pages. You can double click on any of these nets and it will highlight and go over to that section of the schematic where that error or warning is shown. And then you can go ahead and fix it. So as soon as I add an off-page connector, I should expect these warnings or errors at the bottom to disappear. So let's copy this off-page connector. We're going to change the name to LCD power enable and connect it up. And all of our online DRCs go away. I believe that is all of the connectivity that we had on the power page. Let's just double check to see if there's anything else here. Nope, I think that's all the connections from the power page. All the other connections from this microprocessor are actually going to go to circuits on our peripherals page. So let's first go ahead and add those peripherals. Switch over to the peripherals page. Now there's 2 peripherals which we want to add. One is a SD card connector, and then the other is a connector for an LCD screen. First one we're going to take care of is the SD card connector. I believe it is this one right here. And again, I will put a link to a document where you can find all of these parts and match which symbol goes with which footprint, and you can add them to your My Workspace library and follow along that way. Here what we need to do is connect a couple of these pins to power, ground, and also our serial interface. So let's go ahead and copy the 3.3 volt power net as well as the ground, so we can grab those onto the peripherals page. Add that here and here. And let's start connecting some of these up. So this is going to go to switch 2. These here are connected to the chassis, and then our VSS pin is also connected to ground. Now our VDD is going to be connected to this 3.3 volts, as well as a pull-up from the switch. We want a 10K ohm resistor. We can grab one from here. And connect it to our 3.3 ohm power net. Perfect. Now, this switch 1 pin is actually also going to be our card detect pin. So we're going to add an off-page connector. This time we'll use this off-page write, and we'll call it the SD card detect. Now we have a couple data pins here as well. We want the CD pin, we want the DI pin, which is data in, CD being chip detect, DI being data in, CLK being our clock, and DO being data out. And then the data 1 and data 2 pins, I can control select both of these pins, do a right click, go to edit properties, and just set them both as no connect. And here I want to add 4 more off-page connectors, with the CD being SDCS or chip select, this one being SD data in, this will be our SD clock, and SD data out. All right, so we've finished up our SD connector and SD interface. The next thing that we need to draw is the connector for our LCD screen. To do that, let's go into the Component Explorer and grab this 24 position connector receptacle. We'll place it right there. This connector actually connects to a LCD through a flex ribbon cable. The interface is sort of determined by that LCD interface, so you'll just have to take my word that the connection on this is correct. We're going to go ahead and grab this 3.3 volt, which would be our logic voltage level. And then we also want that 12 volt that we created on the power page to power our LCD backlight. So this 12 volt is going to come through a 150 ohm resistor, which I have right here. This is actually a 1/2 watt 0805. So it's a pretty chunky resistor. This is going to go to pin 22. And then we have quite a few ground connections on this as well, on both sides, just to make it easier to draw. Got pin 26, pin 24, pins 25, 21, 11, 1, and 3. And then we have pins 18 and 20 being connected to the plus 3.3 volt net. Let's just spread this out a little bit. We're going to need just a little extra space for all of our signals coming in here. All right, so the rest of these are actually part of this LCD interface. So let's go ahead and draw these pins, all except for pin 19 on this side, which is going to be left unconnected. I believe I accidentally made a connection there. And actually pin 23, we'll connect that in a second. This is the cathode side of basically this giant LCD backlight. So we're going to connect that through a transistor in a second. pin 19, let's go set that as a no connect. And then on this side, we have everything except for pin 4, I believe. Now, if we draw, let's say, 2 wires, we can also copy those and quickly connect them to these different pins here, and also ensure that they're all the same length. And then we want to go ahead and add a bunch of off-page connectors. Let's place some off-page connectors. I personally like to just place them with their default name and then change the names through here. One other thing I want to show you is that you can select multiples of these. Right click, edit properties, and actually change each of these by their Y coordinate. So if you know what the name is, you can sort of change it that way. In this case, let's just go ahead and double click here. I think I may have made a mistake. Yep. It's pin 13 and pin 11. So pin 11 goes to this off-page connector and pin 13 goes to ground. There we go. All right, so this first one is data bit 7. The second one is data bit 5, data bit 3, data bit 1, and then we have WR and CS. These ones here, we have RS, we have RD star, we have DB0, DB2, DB4, DB6, and then this guy here is LCD reset. And then finally, as I mentioned before, this here is the cathode side of this giant LCD backlight. So we need to connect that up to a transistor, in this case a MOSFET. We're going to use a 10K ohm resistor again for the pull down here. Connect that to ground. And there's our pull down, as well as our signal here. And this is going to be the LCD PWM. We're going to PWM a signal in here just to control the brightness. And there we go. So there's our peripherals. We have the SD card as well as our LCD screen connector. Now, if we look in our DRCs, we see that we have a lot of warnings right now saying that there's nets that have fewer than 2 connections. These are all of these off-page connectors, which we basically generated here. So this SD card interface, as well as all of these data bits for this LCD interface, and the control signal, so your reset, your write, your chip select, etc. And this PWM. The easiest way to add all of these connectors to our micro page, in my opinion, is to just add these one by one, or box select. Let's unselect that wire, copy these, and paste them on the micro page. And then we'll worry about where they're connected in a second. Grab these. Don't want those. Control C to copy. Paste it on our micro page. We need this. And we need these 5 off-page connectors here. Okay, now to connect these on the micro page, on the left side here, we have data bit 3 going to pin PB10. We have LCD PWM going to PB11. And the clock for our SD card is on PB22. And our data out is going to be on PB23. On the right side here, we have our SD card detect going to PA08. So let's move these, make some room. We have the chip select, and then the right. DB 1, 5, and 7. There's 1. There's 5 and 7. RSRD. And then at the bottom here we have DB0. We have DB246. And then the LCD reset. And then we have our data in for our SD card and the chip select for the SD card. Now, while I was struggling to align all of these, you can actually take advantage of the alignment function in OrCAD. So if I were to highlight all of these off-page connectors, I can go into Edit, Align, and select Align Left in this case, and it will align them up to the leftmost object so that it's much easier to connect these together. And then simply connect wires or copy these wires and paste them just like so. I'm going to copy these and paste, removing the one extra wire that got pasted here. And you'll see that all of our online DRCs are now gone. Now, I actually forgot there's one more signal that we need to add here, and that's on the power page. So this battery circuit, we want to actually be able to monitor the voltage of the battery sometimes. And we'll do that by adding a voltage divider with some pretty high ohm resistors. We're just going to make some room for it first. And in our Component Explorer, let's go ahead and find the 100 ohm resistor. And place it right there. And we need to make just a little more room here. So let's move this to the side. Okay, and then we'll add a signal here and an off-page connector. We're going to use the right. And we're going to call this the ADC-V bat. So this is the battery voltage going into our analog to digital converter and our microprocessor. And this is going to connect up to PB3. I can also grab one of these off-sheet connectors, place it right on the pin, and then drag it off of the pin, and it will automatically draw that wire for us. All right, we've pretty much finished drawing the schematic. There's a couple small things we still have to do, like going through and setting all of these pins to no connect. And what we'll do in the next video is do our final set of checks, as well as making sure that everything that needs to be not connected is set to no connect. We're also going to take a look at our live BOM, make sure that everything is looking well there. And then we'll go ahead and generate some output files, a net list, so that this project can be taken into a board layout. So thanks for watching. Again, if you have any questions or comments, please leave them below the video and I will try to respond to them as quickly as possible. And see you in the next video.